Welcome to 3.2, Complex Numbers. I'm starting off this lesson with a question for you. And my question I'm going to put over here on the right-hand side is I'm going to say, well, x squared plus 9 equals 0. And in order to solve this, you would subtract 9 from both sides, and you would say x squared equals negative 9. You'd take the square root of both sides, and from here you would stop. And we'd say, uh-oh, no solution. But let's expand our minds a little bit and let's say, well, what if this did have a solution? So let's bring this back over here and talk a little bit about our math career. And so far in our math career, we talked a little bit about numbers, right? Back in kindergarten, we started talking about numbers. We started talking about some like whole numbers. We started counting, right? So we started with whole numbers, things like 1, 2, 3, and then we started to say, well, if there's whole numbers, what about integers? What if we introduce this negative numbers in here? So like -6, -18. We started talking a little bit, like if we go into debt, we could go in the other way on the number line. We even introduced a little bit more, which was then we said, well, there also are things like rational numbers, and those are things like a half, right? You can have half an apple. We could have halves. We could have $2.68. All right, we can have rational numbers. They have a ending point, but they're not quite a whole. They're not right. And then even from then, we said, okay, even there's also these numbers that are, I'm going to put this on the other side, that are irrational. Irrational numbers. Those are things like pi, square root of 2, right? They go on. They don't exactly have an ending point. They exist in our world, but they might be a little confusing on that one, all right? So in terms of this, so far in this pink world of numbers, I'm going to even take this and move it a little bit over because this is all talking about numbers right here. So far here, this is what we're going to call our real numbers. And I'm about to introduce something to you. I'm going to switch over here. Let's choose this purple for this. And this is now a new type of number. It's what we're going to call imaginary. We're going to imagine this number. Imaginary numbers. And the imaginary numbers is what we call I. And I is equal to the square root of -1. And what's so special about I is that I squared then is equal to -1. And all of this now, so now all of our numbers and our imaginary numbers fit under this heading of complex numbers. So we have complex numbers, which can either be these numbers that we're used to, or now it can go ahead and include these new imaginary numbers, or I. And bringing us back to that first question that we had over here, which was, okay, if I have this x squared is equal to x squared is equal to -9, we can go ahead, we can keep solving this now, is that we can say, well, x is equal to, and we can call this the square root of 9 times -1. And the square root, of course we'd say plus or minus on there too, excuse me. So now we can easily take the square root of 9, that's 3, but the square root of -1 now is equal to I. So we'd say 3I. And we are now able to answer these quadratic equations where we had said before, nope, doesn't have a solution. we're now going to go ahead, we're going to imagine and use this imaginary number to go ahead and solve these equations. So let's look a peek at some examples because it's a little easier to put in context. So example 1 is going to be simplifying some square roots. So I'm going to go ahead, I'm going to give you a square root of -4. Once again, we could break that down. Those square roots can be broken down into multiples. So this would be 4 times -1. All right, I'm going to break that down one more time so that you can see it, which is square root of 4 times the square root of -1. Square root of 4 is 2. Square root of -1 is I. And this now simplifies, the square root of -4 simplifies to 2i. Let's try another one. Switch over to different colors. So example 2 here. Let's try square root of -56. I'm going to break this one up into, I know that 56 can be broken up into 9 times 6, but also it's going to be negative, so times -1. So we can now say, well, this is the square root of 9 times the square root of 6 times the square root of -1. When we are simplifying, we know that the square root of 9 and the square root of -1 can go ahead and be broken down into 3 and I, but we have to leave that square root of 6 there on the inside the radical. So just a little bit of notation here. If you'll notice, I'm pulling out 3 and I in front of that radical, which is so nice now because we can solve some quadratics. So let's go ahead, let's solve a few of these quadratics, and then we'll look at some properties of I and a little bit of notation. I'm going to do, let's say, 4x squared plus 20 equals 0. And we, of course, are going to isolate our x squared. So we have 4x squared is equal to -20. Divide by 4 on both sides. So x squared is equal to -5. And at this point, we normally would have said, no solution. But now we do have a solution. We're expanding those minds. So x is equal to, this is now going to be plus or minus, this would be square root of -5. We're going to take the I out of it, that negative of it, square root of 5. So plus or minus I root 5. And this also works with, so example 4, when we have something like x minus 2 squared plus 18 equals 0. So isolate your squared, even if it's in parentheses. Okay, at this point, we're going to go ahead and take our square root. We get x minus 2 is equal to plus or minus, I'm going to break this one down a little bit for us, square root of 9 times 2 times -1, and the 9 and the -1 get pulled out of that root, so we get x minus 2 is equal to plus or minus, and this is 3i square root 2, but we still need to isolate that square, so we're going to add 2, and it's always nice to keep your whole number or your integer, your integer in the front of your equation, so x is equal to 2 plus or minus 3i square root 2. All right, and just going ahead and keep solving those quadratics now, even though we end up with a negative on the square root. So there are a few little properties of I that we should review. Maybe go say properties of I. And as we get going with this semester, there's going to be more and more things that come up with I. But with I, you can go ahead, you can add it and you can combine it. So you have something like 4i plus 2 plus 6i is that we can combine our like terms. So we can combine here the 4i and the 6i, but you always want to write your rational or integer numbers in the front. So we have something like 2, and then 4i plus 6i is 10i. So what we like to say here is that we say keep I left, on the left side of your equation. Sorry, not left, last. Keep I last. Sorry. Just getting tripped up on my words. So keep I last. You want to keep it on the last part of your equation there. All right, let's try one more. I'll keep it as red for this one. So we can also multiply. So we have something like 3i times 2 plus 4i. And when we distribute this, we get, well, 3i times 2, that's 6i. You can just go ahead, you can multiply the numbers on that one. And then this one turns into 3i times 4i. So this is plus 12i squared. And as a reminder, I squared, so let's write this. So remember, I squared is equal to -1. So this actually turns into 6i plus 12 times -1, which is -12. I'm going to write that at the beginning of my equation. So -12 plus 6i. And that's completely simplified there. So just as that reminder there, and switch this over to a different color. Remember, I squared is equal to -1. All right, and one more with these multiplications, just because it's easy to get them a little tripped up. But you guys, as long as you just kind of keep that properties of I, and remember that I goes at the last, and that I squared is equal to -1, should be all right. So we have 3 plus I times 5 minus I. So this can all be FOILed out, right? We can go ahead and we can say 3 times 5 is 15, and then we have minus 3i plus 5i, and then I times -I is -I squared. All right, so in all of this, we can combine our -3 and the 5i, and we also want to remind ourselves that this I squared is -1. And this now means minus -1. So if we write this out, we get 15, and this is 3 minus 5, that's positive 2i, and this is minus -1, which is really plus 1. So 15 plus 1, I'm going to combine that to 16 plus 2i, and that's my final answer on that one. So just a little heads up on those imaginary numbers. And when you multiply them out, you want to remember that I squared is equal to -1, and write the I at the last part of your equation. Good job!